Welcome back for watching the last video for our end of course practice test. So this should be around number 16. So in this video we're going to take a look at these last problems. I believe this one is number 16, and this is also one that we did have in lesson 8 too. I went ahead and put this problem in because I knew it was one of the release questions. And so we'll still go over it though today, so that if you did have some difficulties on it, it may help out. So the sine of angle F is 0.53. What that means is that if you think of sine and SOHCAHTOA, then your ratio is what that's referring to, how you get a fraction. I'm going to do this problem, but through kind of just using different numbers to kind of prove how this works. So the sine of F, and let me go ahead and just make this a 5, 12, 13 triangle, because that way it doesn't give us the same ratio as 0.53, but we will get to see this comparison. If I look at the sine of F with these values, then that means that my ratio for sine, we want opposite over the hypotenuse. That would be 5 over 13. Okay, let me kind of switch colors here. And what if we wanted to look at the cosine, but of this angle? So saw and then so cosine is adjacent over hypotenuse. So if we think of the cosine of h, it is the adjacent. Now all of a sudden, that 5 becomes the adjacent side. So here, our cosine of h would also be 5 over, and this is still our hypotenuse, so 5 over 13. What do you notice about these values? They are the exact same. So when it says the sine of F is 0.53, you don't even have to know anything else really, because the sine of one angle is equal to the cosine of the other angle. And so your answer for this one would have just been 0.53. They should be equal. This next one is a proof. So let's go ahead and take it step by step. We are given that WY is congruent to WX. So that is where these are marked right here. That's given information. And ZY is congruent to ZX. So ZY, that's where these are marked with 2. So we do have both of those marked up here. And then the next thing that it says is WYX. So angle WYX would be this one right here, is equal to WXY. WXY is here. Remember, the vertex is listed in the middle, so that helps you to find these angles if you're having difficulty with finding the angles. We also know that angle 3 is congruent to angle 4. Now, how would we know this is the question, because we want to know our reasonings. You can look at your possible options to help out. One thing that you want to keep in mind is the only thing we've been given are the side lengths being congruent. If we think about how our sides are congruent, and then that means that we have some congruent angles, there's 2 sides that are congruent. Those are the opposite angles. That is the base angles of our isosceles triangle. So that's what would go here. I'm just going to write base angles because otherwise that would take me forever. But our base angles of isosceles triangles are congruent. So keep in mind, just as a recap in case that doesn't sound familiar, isosceles triangle has 2 sides that are congruent. The base angles are the ones that are crossed, which is kind of what we're given in that picture. So that's what that's referring to. Next, it says for our next step that measure of angle WYX is equal to the measure of angle WXY, and the measure of angle 3 is equal to the measure of angle 4. That's just because congruent angles are equal. If you know that 2 angles are congruent, their measures are equal. The next step says that the measure of angle WYX is equal to the measure of angle 6 plus 3. If you look at this angle, it's really just made up of that 6 and that 3. That is considered the angle addition postulate. So if you look at these, Let's look at the next one, just to double check. That's what I was referring to, sorry. So measure of angle WXY is this one, and 5 and 4 do add up. So that is the angle addition postulate, which you do always want to make sure, even if you think you can look at these as hints, but you want to make sure that those are one of the possible options too. So then measure of angle 6 plus measure of angle 3 is equal to the measure of angle 5 plus the measure of angle 4 just by substitution. They give us that. Now what we want to think about as our next step is looking at the fact that we have the measure of angle 6 plus the measure of angle 3 and then 5 plus 4. But we need to narrow that down to 6 and a 5. So you want to think, is there any way that we can get rid of that 3 and the 4? One of the ways, since we know that the measure of angle 3 is equal to the measure of angle 4, is that's what we could substitute in. They tell us our reasoning of substitution. So substitution means that you're going to put in place something that has the equal value of something else. If we look at our possible options that are up here, this is kind of moving things around, so that probably wouldn't be it. If you look at this, they do put 2 measure of angle 3 in there, but we know that it really needs to take the place of this one, right? Because it's equal to measure of angle 4. So this would be the correct one for this step. Because measure of angle 3 is equal to measure of angle 4, so you can plug that in place for it. Measure of angle 3 is equal to measure of angle 5 plus measure of angle 3. Then your next step is the measure of angle 6 is equal to the measure of angle 5. Well, if you notice that you have the same thing that's being added to both sides, then based on the addition property of equality, you can get rid of it. So that is the addition property of equality. Now, if we look at these, we know that we have SAS. Let's take a look at how we know. If you look at our big triangle, we have this side, this angle, and this side. So if we look at that part and what we know, then that's going to be one of our triangles, WYZ. And that should be congruent to, if we start up here at the W and we take to a side and then an angle and a side, you would be at WXZ. So pay close attention to what's given, the way that I knew to highlight those. Let me go ahead and kind of take some of this writing off because I know it gets kind of hard to follow along because I've got a lot on here. But let's go ahead and look. So we've already mentioned that our angles are congruent. Let me put that part back up here. And some of the things that we ended up is we do know that 6 is congruent. That was with that last step, that's congruent to 5. So side, angle, side. And you basically will just do side, angle, side. But then if we want to connect those triangles, that's how you know which ones you're really looking at for that. Another thing that you could have done is looked at the options here. If you highlight those options, do you have a side, angle, side relationship? That could have helped you to figure out which ones were correct also. But that is using SAS. So now, if we use SAS, we know that those triangles that are mentioned up there are congruent. Then the next step says that angle YWZ, so YWZ would be this one right here, has to be congruent to XWZ, which would be this one. Almost every single time that you have congruent triangles, if there is a step after this, always see if it is corresponding parts of congruent triangles are congruent. Because that's exactly what this is. Because we know that we have congruent triangles, we know that those parts are congruent. So that's the CPCTC. Be very careful though, because notice how similar this is to this. This is the wrong answer. Even though it looks a lot like it, that uses the word similar, where we are talking about corresponding parts of congruent triangles are congruent. And last but not least, WZ bisects angle YWX. We know that it bisects just because of the definition of an angle bisector. Because if those two angles are congruent, that is essentially what makes an angle bisector. So angle bisector. For some reason it's not wanting to write up here, but that's what that should be saying. Definition of angle bisector. Sorry, it won't write properly right now. But that is every single step of this proof. Some things to keep in mind with proofs is really looking at it step by step will help. This one has a fair amount of blanks. If you miss a couple of these blanks, though, you miss that full point from this problem. So after you do it, I really recommend reading over it again. See if everything makes sense. Make sure that you're using the given information as hints to try to help you get those missing ones. This one is also in class right now because we are actually talking about dilations, but I will go ahead and put it in this video. That way, if you do miss it and you're watching this, you can take a look. So the equation of a line is shown. And we want to see the dilation centered at 0, 0 with a scale factor of 6. We're going to have to identify the slope and the y-intercept, so I recommend putting this in slope-intercept form, which is y equals mx plus b. In order to do that, that just means that we are going to solve for y. So 6x minus 3y equals 5. You can make sure that you subtract 6x first to try to take that to the other side. This will cancel. Negative 3y equals negative 6x plus 5. Keep in mind right here is one time where if you have a habit of combining those, remember that you can only combine like terms. You can only combine them if they have that same variable. Since the negative 6 has an x, but the 5 does not, then those are not like terms. You just write them out just like they are. Then you're going to divide by negative 3 to get y completely by itself. So y is equal to 2x minus, because it is a minus 3, minus 5/3. Alright, when we talk about dilations, which is just this week, keep in mind that there were some notes that I gave you, and that is that if you're talking about dilating a line or dilating your figures, your slope is the same, and any point that you want to find, though, you multiply by the scale factor. So looking at this problem, if our slope is the same, remember slope is the m. So the m is the number right in front of your x, so your m is a 2. So your slope is the same, that should be a 2. For b, what is the y-intercept? Your y-intercept is this number back at the end. So if you take that, that's just a point. That's a point where it crosses your y-axis, and so you would multiply that by the scale factor. It said in our problem the scale factor is 6. So times 6. Negative 30 divided by 3, negative 10. So this one would be a negative 10. Okay, this one should be probably about number 20, maybe the last, or no, this is 19, probably the second to last one. So with this one, it says triangle MNO is transformed to produce triangle PQR. Select all of the transformations that would guarantee that triangles MNO and PQR are congruent. Alright, so at first you want to notice that there is no graph, but what you want to think about is this fact of being congruent. In class, we use the word rigid motion even, though, just in case that term is put in here. Rigid motion means ones that turn out to be congruent, and we talked about how anytime that you have a translation, anytime you have a reflection, or anytime you have a rotation, those result in congruent figures. Those are examples of rigid motion. The one where it is not congruent is the last one that we talked about, which is the dilation. So dilation gives you similar figures. where the other three would give you congruent figures. So if you have a dilation then a transformation, that wouldn't work. The dilation changes the size. If you have a reflection then a dilation, that wouldn't work. The dilation changes the size. If you have a reflection and then a rotation, that would work. If you have a rotation and a translation, that would work. If you have a translation then a reflection, that would work. The only thing that you could not have is a dilation. So any other possible combinations would result in a congruent figure. All right, here is the last one that we're going to take a look at. So Rosa collects data on which students at her school like to eat at the movie theater. She asked a random sample of 120 students 2 questions. Do you like to eat popcorn at the movie theater? Do you like to eat candy at the movie theater? Her data is partially shown in the table. Of the students she asked, 60% of those who eat popcorn also like to eat candy. We need to try to complete this table. This is a frequency table. We will get through a lesson. We'll do some more examples for frequency tables. There were several throughout this practice test, so hopefully this will kind of help out. But what a frequency table is organizing your data, and keep in mind that your totals should add up going across and add up going down. If this is the total of students, and you know that 70 of them like popcorn, that leaves 50 that doesn't like popcorn, because 70 and 50 add up to 120. So you could always think 120 minus 70. Then we could also figure out the total that like candy, because if there's 120 total and we know that 62 don't like candy, then that's going to tell us what we have left, which is 58. So this number would be a 58 right here. Now, we don't have any other boxes though, so you might be thinking, okay, well, I don't know what else. We want to look back in the problem though. Remember to read through your problems a couple times. It says right here that of the students she asks, 60% who eat popcorn, so we want to just look at those that eat popcorn, 60% of those also like candy. So if we take that 70 and we multiply it by 60%, which anytime you use a percentage, you do have to put it into the decimal form. So our decimal form of 60%, you just move the decimal place over as 0.6. And 70 times 0.6 gives you 42. So that means that 42 would go here. Now we can go ahead and finish our chart out. We have 58 minus 42. That would give you 16 right here. Hold on. And then if we have 50, we could do 50 minus the 16, going, if you look down, because there's 50 that don't like popcorn, but 16 that like candy. Let's subtract those. This would be a 34. And then don't like candy, you could do 70 minus the 42, which would give you a 28. Sorry, this isn't wanting to pop up as I'm writing. I'm not sure why, but 70 minus 42 would make this number a 28. You could always check just to make sure that you have this right. So 42 plus 16 is 58. 28 plus 34, 62, 70, 50, 120. Counting down, 42 and 28 does give you 70. 16 and 34 does give you 50. 58 and 62 does give you 120. So these should be the correct values. Hopefully these reviews are helpful. Please let me know any questions that you have as I've went through these problems. If you have additional questions, if you're not sure why I did any of the steps that I did, just make sure that you let me know and continue to keep up the hard work. We will definitely see some more end of course practice tests from previous tests before we do take the test. And if there's any other questions or anything else that might be helpful for you, just let me know.